For today's video, we're going to be taking a look at some of the coolest AI hardware from 2025. To begin, I think it makes the most sense to start off by looking at some of the most affordable and beginner-friendly devices that currently exist in terms of using AI. Things like the Nvidia Jetson or Nano Super, a small, currently $219 little AI desktop supercomputer, air quotes, something that really makes it easy to get hands-on experience with AI, and relative to the actual price and size, packs a decent amount of power for some AI workloads. So let's talk a little about this Nvidia Jetson, the device that I've chosen to begin this video with showcasing, because truthfully, this device, since its release about a year ago, has represented a very entry-level and attainable device to actually learn about AI. Now, AI on my channel is often associated with talking to smart large language models, testing them, making fun games, and things like that. Truthfully, it encompasses so much more, and the Jetson represents a fantastic device to actually give folks hands-on experience with local AI, which goes far beyond just running a language model. If we go ahead and actually take a peek at the Jetson AI Lab website, which has been redesigned, so truthfully I am a bit less familiar with it, we can see that there's a bunch of tutorials here that go far beyond just running a simple LLM. There's a lot of things with vision and multimodal capabilities, which we'll look at a little more with the Raspberry Pi, but take a look at this Nano Owl tutorial right here. This runs something with an attached camera that you would obviously get, but the cameras are widely available and kind of a specific size, so they are applicable to like Jetsons, Raspberry Pis, and a bunch of other things. They just use something called a CSI cable to connect to the camera, so very attainable devices. And with that, you can actually run a machine learning program right here that can be told what to specifically identify in a live video feed, and it will draw bounding boxes around any specific thing you tell it to identify, such as a person. I've tested this with laptops, and when I moved my head down, there was a shelf behind me with a ton of laptops, and a bunch of bounding boxes showed up with laptops in them. And I truly believe this probably represents one of the best values for an educational device in the current AI-specific hardware landscape. It's got enough horsepower to do some cool things, but it is not going to be a replacement for ChatGPT or something like that, so I do believe this is more of a kind of learner hands-on device. However, it does have some pretty cool and unique use cases beyond just sitting on your desk as a computer, such as, have you been feeling stuck? Like you haven't done anything cool with your Jetson or a Nano Super? I'd run some LLMs, but I still felt like there was more I could get out of the device. That's when I found out about social robots. I'm struggling to see how the moon landing would have anything to do with this.
Oh, and I have a strange fascination with alien conspiracy theories and believe that cats are actually plotting to take over the world.
Side effects may include laughing, having a great time, and becoming better at programming. Thanks to Social Robot, I now feel like I've used my Jetson to its full potential. While I know I did just say that this can do so much more than run LLMs, I still kind of get a kick out of seeing it actually run a large language model locally and offline. So right now we're just using a very simple tool called Ollama, which through our command line here or terminal application will actually load the Qwen 3 4 billion parameter language model, a very potent yet small language model that runs entirely offline on this Jetson device. And as we do this, I'm actually going to go ahead and turn off my internet. So there we go. And we'll basically see that this is running entirely on the device. Now, you'll notice that it kind of takes a while to load in and respond, and there are a bunch of different open source language models of varying sizes, so you don't have to pick a Qwen 3 4B. Google has their Gemma family of language models, which will run quite happily on this device, and we'll actually be able to play with some of those later on when testing some other devices in this video. So just like that, we have our Qwen 3 4 billion parameter model, and let's just ask it to tell us a story. And we're going to see that with this specific setup, just using Ollama through the terminal, it is very basic and kind of cyber hackish aesthetic, if you will. However, there are web interfaces that you can run to make this look more like ChatGPT and still use this model on the back end on your own local device. Something interesting to actually note that I had neglected to even think before doing this, the Qwen 3 family of models are thinking models. So you may see now in more modern AIs that you use like ChatGPT, Claude, DeepSeek, Google, anything. sometimes they think before answering. So this model is actually the same, where we can see everything here in this light gray was actually a chain of thought, and its answer has culminated here into the white text where we see it denoted dumb thinking, and then it begins to tell us the story, and it's still going a really decent speed. So this is just one of many very, very cool things that this device is capable of doing. And for those who perhaps don't want to get the Jetson for whatever reason, maybe it's not available where you live or something of the sort, there's even just the Raspberry Pi 5, preferably an 8 or 16 gigabyte model if you are planning to do some AI workloads. And if you can get the Hailo AI Accelerator chip, this device really offers a lot in terms of vision-enabled AI workflows, things like object detection and lots of other types of things that involve using cameras. So the Pi 5 is a really interesting and expandable device to actually get hands-on experience with AI, even if it's not specifically marketed as being such a thing. Now let's talk a little bit about the Raspberry Pi. While the Pi has varying levels of performance depending on the specific model that you get, as well as the specific amount of memory that it has, I'm going to kind of stick with the Raspberry Pi 5 for this, and for any AI or machine learning purposes, I would very likely recommend going with the 8 gig or 16 gig variant for the Raspberry Pi. Now, you may notice that my Raspberry Pi, or the specific one we're using, has an M2 adapter on it with a Hailo accelerator. Now, this is a small little AI accelerator that is designed for image detection tasks, and it really expands some of the capabilities of this Raspberry Pi, making it suitable for home security systems and things of that sort. So while this device can handle running LLMs, as we saw with the Jetson, it is not specifically geared towards that, so it can do it, but it's not going to be the best. Image detection, however, especially with something like this Hailo accelerator, is quite cool. So what we're about to see right here is a default example from the Hailo GitHub repository, where this is showing a pre-recorded video feed, and it is actually drawing bounding detection boxes along all the people and other things it sees right here. Now, while this is looping, we can see that it is detecting people, as well as the accuracy figure that it sees when drawing those boxes. It did also, if I do believe I can see correctly, detect a bicycle there when that gentleman was riding by. It's also detecting cars with varying levels of confidence. So this is just one of the many vision-related things that can be done with this Raspberry Pi. Now, in that same vein, although a slightly different example, this is the same demo scene that we see, but instead of doing object detection, this is doing something called pose estimation. So we can see, and this may be more familiar to you if you're like kind of used to doing any game development where you need to rig animations or characters. This is basically just drawing wireframes on these individuals and mapping the way that their pose would go as they're walking. So this is another thing that, even using the same exact demo footage, is a capability of this Pi with this Hailo accelerator. So again, there are so many different cool examples to be seen with this, and it really has a strength in AI-enabled vision capabilities. Now, I had mentioned that the Raspberry Pi can hypothetically run LLMs as well, so we're going to just showcase that real quick with a Qwen 2.5 0.5B model. This is an extremely small and lightweight LLM, meaning it's not going to be the most intelligent thing, but if you want to run a local LLM on a Raspberry Pi, a smaller model like this is a fantastic option. Hey there, and we'll notice this is not a thinking model as we saw with the Jetson, so it just immediately begins its response, and it's very simple, but again, it is kind of the concept or the cool factor of actually being able to run some form of local AI on this device. And as with the Jetson, you can also slap a nice chat interface onto this, something like OpenWebUI perhaps, which just kind of emulates the look and feel of using ChatGPT or some other online-based web chat interface for AI. Now I want to focus on systems that may not even be marketed to running AI. Things like your old gaming rig or something equipped with an Nvidia 3000 series GPU. This in my hand is a 12GB Nvidia 3060 GPU. I bought this a while back for $250, and it's very likely if you have a gaming PC that is a few years old, it has some form of Nvidia 3000 series card or the equivalent AMD card, even perhaps an Intel card if your PC is a bit newer. All of these things will give new life to an old system because they do have relatively acceptable capability in running AI models. So the system we have here in front of us is a relatively antiquated quote-unquote gaming PC, and I want to specifically drive this home because a lot of folks may be under the impression you need powerful, expensive, or new hardware to actually run local AI, and that's not necessarily the case. So let's actually go into the specific system settings here and take a look at what we have. In this case, this is an AMD Ryzen 5 1600 processor, something I do believe is like 6, 7, or 8 years old at this point. 16 gigs of DDR4 RAM. Now, obviously, RAM has become kind of wild in price lately, but still, 16 gigs of slow 3200 megahertz DDR4 is not going to break the bank. And finally, kind of the main event, if you will, is the graphics card in here. So this is an Nvidia 3060 GPU. This has 12 gigs of video RAM and is something I picked up a while back for around $250 new. This system is basically like an old gaming computer you may have kicking around that you don't really know what to do with. And I want to specifically showcase its capability now to actually decently run some local AI. Now, the application we're going to be taking a look at right here is something called LM Studio. This is basically a program that allows you to search for AI models, simply download them, and then go ahead and have conversations with them in a manner that you may be used to if you use online AIs like ChatGPT. So right now, we're just going to pick a decently intelligent model that is still very good and capable to run on this system. So let's use one from Google. In this case, we're going to be using Gemma 3 12B. Now, this is a 12 billion parameter model from Google as part of the Gemma 3 family, and something interesting about this that makes it even cooler that the system is relatively old and cheaper, relatively speaking, is that this model is actually capable of looking at images as well and answering questions about them. So this still has a lot of potency and capability, even for a system that is years old at this point. Now, when we showcase some of the models we ran on the Jetson and the Raspberry Pi, we kind of just said, hey, in this case, let's actually go ahead and highlight some of the capabilities we can get even from an older system like this. In this case, we're instructing Gemma 3 to go ahead and give us a beautiful website for Steve's PC repair. This is going to now go ahead and actually generate the code for this website. So we're essentially using a local coding setup right now on our old gaming PC. Now, I've actually gone ahead and manually stopped this because it did seemingly misinterpret my initial prompt and basically just gave us a layout of how the site would look. No, I want the actual code, so. And another thing that's cool about local AI is, say you're mean to the AI and do fear for the future ramifications of doing such thing. You can basically just yell at them offline and no one will ever know. Not necessarily, I'm somewhat sarcastic. And while we're doing this, you may know, okay, I am on Linux. Most of the systems that I showcase in today's video are going to be running Linux. Keep in mind, LM Studio can run on Windows. It's essentially the same exact UI, and you will get the same exact experience. So don't think you need to have some fancy Linux setup or distribution. If you had this specific PC, but with Windows on it, you would be able to use LM Studio in the same exact manner, which is quite cool. Now, for those somewhat perhaps a bit technically curious, we can see right now that out of the available 12 gigabytes of video RAM on this graphics card, we're currently using around 10.5, and that does include the overhead of actually running a monitor and things of the sort, and temperature-wise is not bad at all, and this is a relatively power acceptably efficient card. So let's go ahead and take a look at the website that was actually just generated for us on this specific system. I do have to note that it did end up kind of apologizing here. All right, and we see that this is a relatively simple and bare-bones site. There are other models that are more coding specific. This model is not necessarily one. This is better for general purpose knowledge and things of the sort, but this is, it actually went ahead and made 2 different pages, a home and an about us, and it added in some CSS and styling. So that is not bad at all. Something else I want to make note of that I don't really have any decent demonstrations, but is a notable mention, is the concept of using these models to actually reference your own data, something referred to as a RAG. A system like this would be perfectly acceptable in actually performing that as well. So say you upload some documents that you have, and there are many tutorials online for how to set up RAG using different models and different pipelines, if you will. This would be a system that could handle it at some simple level, and it is a cool and useful thing to be able to do. Now, the final thing I'm going to do right here is apologize, because I do feel bad that it seemingly got a little sad, so, and we'll send it a heart. Good. Okay, and now it's happy, and basically, but the whole point here is, as I've probably driven home and am beating a dead horse at this point, this is a pretty antiquated and cheaper, relatively speaking, gaming PC, and it's still quite useful in being able to play with AI locally. On the flip side of that, we're also going to take a look at gaming laptops and their ability to actually decently run AI models. Of course, depending on the year your laptop was made and the specific spec of said laptop, it may do better or worse at running AI models, but generally any gaming laptop made in probably like the last 2 or 3 years will have some relatively acceptable capability to actually run AI models. For example, the one in my hand here is a bit newer and probably too heavy to be carelessly flailing around in front of a camera, but it gives us a good insight into some of the capabilities of even a laptop to run an AI model, which up until kind of recently was not something you would expect. Since we showed a gaming desktop running Linux running a local AI, I figure it's only fair to kind of do the polar opposite. This is a gaming laptop running Windows. Any gaming laptop with a relatively modern Nvidia 4000 or 5000 series GPU will actually be quite decent at running local AI. And depending on the amount of available VRAM, you may be able to run some decently large models, but even if not, you're likely going to be able to run the models you can run at a rapid pace. So just as we had used LM Studio in our previous test with the gaming PC, we can also open it, and like I said, it looks pretty much the same and will give you the same experience when on a Windows PC. So in this case, because this is a relatively beefy laptop in terms of capability, we can actually go ahead and run something which is a fairly well-regarded model for front-end coding and web design, which in this case is GLM432B, something that in its current state is going to use around 18 or 19 gigabytes of video RAM, pretty high for a laptop, but this specific laptop is a 5090 mobile, which has 24 gigs of video RAM, and aside from Apple computers, which we will touch upon, if you wanted a high-performance mobile laptop AI machine, this is currently probably about the top of what you would get in terms of capabilities. Now, I am just telling it to, using HTML, JavaScript, and CSS, give us a beautiful website for a GPU rental software as a service startup. We're going to notice a couple of things here. One of that is it's not necessarily going very fast, and this is something you will notice in playing with local AI. The size of the model is going to have a large effect on the speed of the model, generally speaking. Now, that is not something to take as gospel, but this model is pretty much almost filling up the entirety of the video RAM of this graphics card. Were we using a model that was, say, an 8 billion parameter model instead of this big 32 billion parameter model, we would see the speed going at a much higher pace. Regardless of that, though, a lot of folks kind of have differing opinions, but some people just want things to fit and they don't really care too much for the token speed, which is essentially just a measure of how fast it's actually generating text, and some folks want things to be very snappy. Personally, I kind of tend to have a bit more patience for things like this, so being able to have this speed when considering I'm running a local model on a laptop that is still very performant is quite acceptable to me personally. So here's the website that we just had created for us using this gaming laptop with GLM432B. Now, obviously, the actual end result is second to the demonstration of the capability of using a gaming laptop with a modern Nvidia GPU to actually do this, but this is really a acceptably alright website here that was just generated. We have customer testimonials, we have pricing cards, and it did adhere to the denoted prompt, which was for a GPU rental software as a service. Make me a beautiful website. So this definitely did do it. And again, this is just kind of something cool that can be done with a device that isn't even specifically designed for AI. Now let's quickly touch upon some other items in this category that I don't necessarily have to give live demonstrations of. First and foremost, folks may be interested, well, okay, you showed Nvidia equipped desktop and laptop. What if my system has an AMD or even an Intel card in it? Assuming they're relatively recent, you should actually be able to have some level of support for at least running AI models, as we saw in LM Studio. Those software ecosystems are not as mature as what you get with Nvidia, but there is a lot of community support there that does allow a lot of the at least local LLM programs, take that with a grain of salt, to run on those devices at varying levels of speed. So, for example, this is an Intel Arc A750 graphics card, something I purchased a few years ago or a couple years ago, and this could actually handle running some simple local AI, so the possibility does in fact exist for both Intel and AMD cards. Now, what about Macs? In the case of, say, this Apple Silicon Mac Mini, this is an old M1 first generation Apple Silicon device with 16 gigs of unified memory. A lot of folks have actually come to really love using Apple machines for local AI because they have large amounts of unified system memory, meaning there's generally a lot of RAM available to actually run local AI models. Kind of in the same vein that we spoke about the software support for Intel and AMD cards, Apple's kind of there as well, but I do have to say the open source community that I've seen for actually running local AI on Macs seems to be very well supported, and the systems are predisposed to being very good values, surprisingly, for using local AI because of the way their RAM is set up. So Apple Silicon, while I don't have a strong enough machine that's kind of set up to run AI to demonstrate it, is definitely a very favorable choice in this current AI landscape. Next up, we're going to take a look at devices that are more strictly kind of existing for AI workloads. Things like Nvidia's DGX Spark, a prosumer or even just a professional level device that is aimed at people working in the field who use machine learning and AI models every day. So here's the Nvidia DGX Spark with its 128 gigs of unified system memory. Now, this is available as the Nvidia DGX Spark, which is the little gold box. However, there are a bunch of other manufacturers that are making these as well, and I do believe some of them may end up being a bit cheaper, things like Dell, HP, MSI, etc. So something we see right here, and keeping in mind these devices, or this device in specific, is kind of more, I wouldn't necessarily say consumer focused. This is very likely designed for a specific niche professional individual who is actually going to take advantage of some of the deeper capabilities of this device, some of which we can see in these available quote-unquote playbooks. Things like actually training models, fine-tuning models with things like unsloth, optimizing specific models to run at high performance in some of the things that this specific GPU or chip supports, such as the NVFP4 quantization. Now, I suppose to just showcase something cool about this device, this is going to be running Alibaba's WAN 2.2 video generation model to generate a prompt, which we see right here, which is essentially a neon lit cityscape where someone walks in and it almost looks kind of Tron style with a grid. Now, being able to perform this video generation here using Comfy UI is just a small sliver of the capabilities of this device. It can handle much larger LLMs such as OpenAI's 120B OSS or GPT-OSS AI model, which seemingly has become widely regarded as decent after perhaps an initial turbulent response by the community when it was released. But again, more of this is really professionally focused, and that is kind of reflected by these DGX Spark playbooks, which we see right here, a lot of which are denoted towards specifically fine-tuning or even training models from scratch. And this is a system that you can actually demo some specific things that are intended to be deployed on very expensive, high-powered data centers. So it's a little AI supercomputer on your desk as they market it, and it definitely fits. So here is our generated result. WAN 2.2 is very well regarded for its capabilities, especially being an open source video generation model that can be run offline. There are many different aspects of customizability for all of these image or video generation pipelines. This is using Comfy UI, which you may be familiar with, and I don't intend to show this as something that necessitates a device of this level. You can probably run this on a higher end consumer GPU, even like a 4090 or a 5090 or something of the sort. The point is, this just kind of touches the surface of how intricate and powerful this specific system is, and keeping in mind a lot of the specific focus for what this is used or marketed for more is in line with creation of models, fine-tuning, and more kind of technical deep dive things. But it does also function as a cool little AI computer that is capable of running large models, video models, image generation models, etc. In that same vein, although a bit more attainable, would be AMD's Strix Hailo, or as it says here, AMD Ryzen AI Max Plus 395. Both of these systems have large amounts of unified system memory, and that allows them to run rather large local AI models, which is kind of cool. So this is the AMD Ryzen AI Max Plus system, known also as the Strix Hailo. The specific one we're playing with today has 128 gigs of unified system memory, just like the DGX Spark. Now, the difference with these two systems are, aside from the fact that this can actually run Windows and does by default, in this specific case, which mine is a GMK Tech product, does actually ship with Windows 11, though I have opted to go for Ubuntu on it. This is a system that provides a large unified memory pool with a relatively affordable considering what other options do exist price point. Now, when I purchased this, I believe it was around $1,800 from my local micro center, and I noticed the price seems to have creeped back up to a little over $2,000, perhaps due to RAM price increases or whatever the specific factor may be. This is a device that really is fantastic for running larger local AI models because, like with the DGX Spark, it's not going to be the fastest thing on the market in terms of raw tokens per second speed, but the way that it sips power comparatively to a dedicated graphics card, as well as the large pool of unified memory, makes it a fantastic option for running some fairly heavy-duty local AI models on your own system that fits on a small desk corner. Now we can see on this device we're running OpenAI's GPT-OSS 120B open source model. There were two sizes that came out, a 20 billion parameter as well as this 120B. So this is a pretty big and power intensive model that, to be able to run locally, requires some more intense hardware, such as this Strix Hailo. So this is a really cool device, and as we can see right here, this model is currently thinking because you can actually manually change the amount of reasoning effort that it uses as well. I have tasked it with making a simple web-based 3D flight simulator game, but regardless of whether or not the result actually functions or is playable, the whole point here is this device is really a fantastic value for running local AI. It's poised to be able to do multiple things. I mean, a lot of them do come with Windows, so you could probably just use it as a tiny gaming desktop PC, which it seems to be pretty good at as well. But for AI specific use cases, this thing is really fantastic. Now, some of the downsides of this is the software stack for AMD or this specific GPU or system is not as mature as what you would find with an offering from Nvidia like the DGX Spark, but there's a lot of community work to actually get things like 2.2 video generation working, getting image generation working. And regardless of that, out of the box, this, as we see here, does run AI models fantastically well. And for good measure, let's see if our plane simulator game actually does work at all. Okay, well, it doesn't necessarily seem to, but again, this model is not specifically designed for coding capability, and this specific task is perhaps a little outside the realm of what would be possible with such a local model. But if you are interested in seeing what these games do look like, you can head to ultimateplay.com, which is my own website, and I am not trying to sell you anything because there's actually nothing to buy on this website. It's just somewhere where I like to actually post some of the results from AI models. We can score them, and this is something that is a passion project, and I intend to actually keep updating it more so than I have right now. But for example, here's a flight combat sim that Gemini 3 Pro made, which is pretty darn cool. And if I don't I'll get distracted with this easily, but I did just kind of want to show that because the one we just generated didn't work, so I did want to, showcase it. Finally, we're going to look at some more obscure and niche devices, things like the Tenstorrent Wormhole system behind me, or even the first foray into a true consumer AI device like the Olares one. And to get even weirder, we're going to take a look at a gaming phone and its ability to actually competently run some smaller AI models. So here's the system with the Tenstorrent Wormhole N300D card in it, and I think the best way to summarize what this is that it is listed as an alternative for machine learning developers who want to use something aside from a GPU. Basically, this has full access to all low levels of its hardware. It is a rather unique architecture, and this is something that is really designed for like hardcore students, engineers, professionals, and really it's rather difficult to wrap your head around some of the complexities of the hardware of this card. So with that, we're just going to do a simple demonstration here where basically here's a cool look at our specific card running in the machine behind me right there with the two fans going. It is just such a cool looking piece of hardware. We can see that we have our board. It has two separate processors in it, each with 12 gigabytes of RAM. So this has 24 gigs of total memory on this card. And we can see a little bit more information here like core voltage, power, temperature, the firmware for our card, telemetry, and then kind of information just like this. So this is a really complicated and very intricate, cool piece of technology designed for a very specific type of consumer, and it's something that is just wicked cool. While the Tenstorrent Wormhole is designed for really intricate, low-level programming and people who really have a grasp of what they're doing, the Olares one is kind of the opposite. This is almost one of the first AI appliances that we've seen on the market, and really it allows anyone to basically remotely access this device, which is designed to be a local AI server from basically anywhere. So I'm not even connected to the actual Olares one physically, I'm just accessing it through the web URL, and it has a market application which makes a lot of these machine learning programs and things really simple to actually just one-click install and then give access to anyone who you want. Yourself, family, friends. I mean, you could even charge people to access your specific Comfy UI service on this or something of the sort. So this is a really unique device and something that is kind of one of the first more consumer, almost appliance-focused AI-specific devices. And it's just kind of neat. So one of the final things, basically the final thing I want to show here is something that does not really get a lot of attention currently, and that is the concept of running a local AI on mobile phones. Now, in this specific case, this is an Asus ROG phone with 24 gigs of system RAM, allowing it to actually run some fairly large for a mobile device size LLMs. In this case, so this is an Alibaba open source application called MNN. So it's from MNN, which is like a subgroup of Alibaba. Don't quote me on that. It's called Tau Avatar. And it actually has this little 3D avatar that you can rotate around and speak with. And I've gone ahead and actually swapped in an uncensored, very tiny language model to power this entire application, making it relatively entertaining to speak to. Mobile phones and AI are something that are probably going to reach a point of more popularity in the coming year as phones become more powerful and smaller AIs become more capable. So even some of Google's models, they had the specific Gemma, I believe it was the IT family, where they actually had specific metrics on how much each token used in battery or how much running the AI actually used in the phone's battery. So this is an area of exploration that a lot of big companies are eagerly looking into, and I believe that seeing AI on phones and things like that may become far more prevalent in the coming year or two. So maybe this will be the equivalent of like looking at the video game Pong from today's lens. Maybe this is what looking at this will be like in a few years. Who knows? So that's going to conclude a look back at some of the really cool AI devices from 2025. I have no doubt that the upcoming year is going to be equal to or greater than, excitement-wise, of some of these devices here, especially considering that CES 2026 is kicking off in like a few days from now. Well, give or take a few days times a few additional days. But regardless of that, if you have any questions, please feel free to leave them in the comments. Thank you for watching and subscribe.